Hello everyone. So, today we will study common base configuration of this NPN transistor. In case of common base configuration, the base will be common in case of input as well as the output. So, in the circuit there are I have represented this connection by circuit symbol and by structure wise also. So, in case of common base, this one is base, P type semiconductor will act as the base. So, this base will be common in case of input as well as the output. And so, in case of input waveform, we will plot the input current, that is IB, versus the input voltage VBE. In the same way, in the output characteristics, we will plot the output current, that is the collector current, with the voltage, output voltage, that is VCB. So, first we will focus on the input. So, now forget this N part and only concentrate on this p-n junction diode. So, this p-n junction diode is in forward bias, and the input waveform for this IB, for this forward bias configuration, the output will be simply look like a p-n junction, output of a p-n junction diode. So, at 0 point up to, if you consider this one is silicon semiconductor material, up to 0.7 voltage, you will get 0 voltage. Why? Because whenever the external voltage will dismiss the internal voltage, up to that we will not get any current. So, when this external voltage will dismiss the internal voltage, after that only we will get the current. Now, suppose if we consider, suppose VCB1 is equals to 0, that means we have considered this reverse bias voltage is equals to 0. So, what will be the output waveform if you want to increase this reverse bias voltage? So, if you increase now the reverse bias voltage, then obviously the barrier at this p-n junction, second p-n junction diode will be more. So, when the p-n junction, in case of this p-n junction diode, the depletion zone will be more, then the depletion region will penetrate more in the base region. So, for this reason more electron will be carried over this collector region, collector end. So, the collector for this one, the IB current, the base current will be increasing. So, whenever you will increase the VCB, the current you will get more. So, that is why we have drawn the input characteristics of this common base configuration. So, whenever we are increasing the VCB, collector base voltage, the output waveform will be more, the output, that means the IB current will be more. So, this is the input waveform, input connection for this common base configuration. Now, to design this output waveform, first we have to get the equation. In the last class we have derived this equation, that is IC is equals to IE plus IB, though the value of IB is very less, because 99% of electron will cross this base region and come to this collector region. So, IC is almost equals to IE, we can neglect this term, but this is a real equation, that IC is equals to IE plus IB. And there are also another equation, that is IC is equals to alpha IE plus ICBO. Now, what is alpha? Alpha is common base current gain. So, and the value of alpha is from 0.95 to 0.99, that means from 0.95 to 0.99, that means 95 to 99% of electron can cross this base region and can collect over this collector region. So, this one is alpha. So, if and this ICBO is reverse saturation current, the amount of this reverse saturation current is very negligible. So, if you consider that IE is much more greater than ICBO, then we can conclude that IC almost equal to IE, alpha into IE. So, the common base current gain value IE is the output current by the input current, that is IC by IE. So, by numerical problem, you can calculate the current gain, common base current gain, by dividing the output current and input current IE. So, this one is the equation by which we can draw the output waveform. So, this one is the output waveform, this common base configuration. From this equation we can say if IE value is negligible or IE value is equals to 0, then we will get very less amount current, that is ICBO, reverse saturation current. That is why we have drawn the waveform like this one. So, this one is a reverse saturation current. Now, in the next case when we increase this IE, then obviously the IC will be increased. So, suppose this one is 5 milliampere, the IE current is say 5 milliampere, depending upon the alpha, which is almost equals to 1, we will get almost equals to the same amount of collector current. So, we can calculate this, if you get the value of IE, we can calculate the value of IC, that means the output current, and this region is behaves like an active region. There are two other region also there, saturation region and cutoff region, and these two region is behaves like a switch, and this region is active region where we can calculate the amount of collector current or IC.